Hello, my name is Yoshida.
And my name is Elizabeth. Our project is, drumroll please, how effective is disinfectant in the average public school?
To go more in depth, is it possible to see how effective bacterial disinfectant is? What is the average bacterial lifespan on most surfaces?
Our hypothesis was that bacterial disinfectant used in schools is about 70% effective.
We also hypothesized that there will be visible bacteria in the samples taken from a CEPS, Common Elementary Public School, despite students and staff sanitizing their hands and janitorial staff sanitizing surfaces.
Our project basically consisted of swabbing places around our school, incubating the bacteria swabbed, observing how much bacteria grew, and testing the effectiveness of the school sanitary products.
The purpose of this experiment is to test the sanitation of a CEPS.
It is also to spread awareness of what bacteria linger on surfaces that we use in our daily lives.
There were many struggles during this project, one of which was our light bulb, a key part of our incubator, breaking near the beginning of our project.
We got a new light bulb, though during the replacement period, we tested the swabbing without an incubator, and it was successful.
Our first thought of growing bacteria without an incubator began when we first created the nutrient agar.
The nutrient agar pack was able to fill 8 petri dishes.
This meant we had to set all the petri dishes the same day.
This was not how we would prefer it to be, but it was okay because we learned how to store it for long periods of time.
Although we did try to store it properly, bacteria still grew in each container, which gave us the idea that the petri dishes do not need to be incubated to grow bacteria.
Anyway, the specific places that we swabbed are listed here on our observation chart. So as you can see, it says music chair, Chromebook, locker bay doors, music room doorknob, bathroom door, water fountain button, and growth without swabbing twice. These were petri dishes that were just too filled with bacteria that we couldn't swab with them.
These pictures over here are the specific end result.
Yes. So these 3 pictures were shot before the swabbing process had been complete. As you can see, it says before.
We chose these 3 because they were the most successful tests.
As you can see, there was a great difference between before and after. Before means before swabbed, and after means after swabbed and incubated. So, yes.
And disinfection, over here, means after we disinfected the petri dishes.
Unfortunately, there wasn't a great difference between after disinfection, after incubation, and after disinfection.
Before the project began, a lot of background research was necessary.
We weren't able to showcase all of our research, but these 2 bacteria were the most popular. Staphylococcus aureus and Staphylococcus warneri.
As you can see in our observation chart over here, they were assumed to be the bacteria on multiple occasions.
A Staphylococcus aureus is essentially the bacterium of pink eye, and Staphylococcus warneri is basically a common commensal organism found on human and animal skin.
You must take into account that because of our lack of technology, we were unable to identify the exact bacteria, and all bacterial labels are assumptions for us.
Some other organisms that we believed were seen in our tests were Pseudomonas fluorescens/putida, a pathogen causing nosocomial infection, especially in immunocompromised patients, though usually only occurs when there is a great amount of exposure to this bacteria.
Klebsiella pneumoniae, the bacteria that thrives in your intestines, though does not cause infection or illness. It can generate pneumonia when spread to other parts of the body.
And Enterobacter cloacae, a commensal microflora in humans and animals' intestinal tracts, as well as pathogens in plants and insects.
Before our project began, we also learned how to create an incubator because we did not have a bacteriological incubator.
This process was quite easy and I have to say fun.
What we did was cut rectangles out from 2 yogurt containers.
As you can see here, we have examples. This was a rectangle cut out, and this was this.
One larger than the other, and put reflective tape on the larger container.
I'm not sure you can see the reflective tape, but it's there. We then poked holes into the bottom of the smaller one, and 1 hole in the bottom of the top one for a thermometer. We then got a lamp and propped it up next to the incubator.
We put our thermometer in and tested how close we need to have the lamp to the incubator for it to be the right temperature.
The incubator stayed at a temperature of around 35 degrees Celsius.
The next stage was swabbing.
This was pretty simple.
We went to the suggested places from our survey, as seen here, right here.
Yes, and to swab, we went to swab. And to swab, you press the swab to a surface. Sorry, example swab. You press the swab to a surface and rub it around so the sample gets all over the tip of the swab.
You then take it back to the petri dish and rub it back and forth in this fashion.
Yes. With an incubator, it takes around 2 days to grow, but it does not show the bacteria as clearly.
Without an incubator, it takes 4 days to grow, but the growth is much more clear.
After both incubations, we compared all of our results. We looked closer at all the samples with a microscope and saw all the growth.
We learned that the Chromebook tested had the most bacteria and the water fountain button had the least bacteria, as seen right here.
Yes. You kind of blocked it.
Sorry, right here.
We then began the process of disinfecting each sample.
Half the petri dish was disinfected with common spray disinfectant found in classrooms, the other half with school hand sanitizer.
We waited a generous amount of time to see the results, and unfortunately they were not as developed as we were expecting.
We estimate after seeing the results that the disinfectant agents were about 30% effective.
And the sanitizer was more successful than the common disinfecting spray.
This may have not been completely accurate because of the conditions surrounding the experiment.
The sanitizing agents were not applied normally due to the lack of professional materials.
We suggest that people pay much more attention to the surfaces they touch and what could have touched the surfaces before them.
We would also like them to spread more awareness about this topic.
Before we end this video, we'd like to thank our gracious science teachers for supporting us with materials, new ideas, and solutions for problem solving along the way.
We would also like to thank Madame Connolly and all the other staff who were there to lend a helping hand when we had an issue with our incubator.
Great thanks goes to the staff and students who completed our survey.
Thank you for watching our video. Have a wonderful day. Goodbye!